Hi kids, today we'll continue current electricity from class 9. I've already made two parts. You can click on the I button and get the link. In today's class, we'll discuss about potential difference between 2 points, resistance, Ohm's law. We'll discuss the factors which affect resistance and we'll do numericals from exercise 9b, concise physics. So let's get started. Now what is potential? Look carefully. In simple term we can say the quantity which determines the flow of electron between two conductors. Suppose joined by a metallic wire. So अगर दो कंडक्टर है आप दोनों को ज्वाइन कर दोगे तो electron from one conductor which has more electron, excess of electron, will flow to the conductor having less number of electron, deficiency of electron, until and unless the concentration becomes same. So potential is the factor वो decide करेगा कि किस कंडक्टर से किस कंडक्टर इलेक्ट्रॉन फ्लो करेगा. फॉर एग्जाम्पल लुक ओवर हियर. सपोज आपके पास एक पॉजिटिव चार्ज्ड बॉडी है, कंडक्टर है. इट हैज अ डेफिशिएंसी ऑफ इलेक्ट्रॉन. मान लो हमारे पास एक नेगेटिव चार्ज बॉडी है. नाउ दिस हैज अ एक्सेस ऑफ इलेक्ट्रॉन. नाउ सपोज मैं इसे एक मेटेलिक वायर से ज्वाइन कर दे रहा हूं. देन व्हाट विल हैपन? यहां पे एक्सेस ऑफ इलेक्ट्रॉन है, यहां पे डेफिशिएंसी ऑफ इलेक्ट्रॉन है. सो इलेक्ट्रॉन फ्रॉम सपोज दिस इज बॉडी ए, दिस इज बॉडी बी. बॉडी बी से बॉडी ए तक जाएगा. इलेक्ट्रॉन will move from body B to body A, conductor B to conductor A, and then we say that the current flows in this direction from A to B. See, electron flows from B to A in this case. Current is I, we have done it earlier. Current flows from A to B. सो पोटेंशियल डिटरमाइन करता है इलेक्ट्रॉन कहां से कहां फ्लो होगा और करंट कहां से कहां फ्लो होगा. नाउ लुक केयरफुली. ये हमारा डेली एक्सपीरियंस है कि सपोज एक बॉल है, वो व्हेन इट फॉल्स फ्रॉम अ हायर लेवल टू अ लोअर लेवल, इजंट इट? हायर लेवल टू अ लो लेवल. एक और केस ले लो. सपोज आप दो बॉडी ले लो. ए, इसका टेम्परेचर T1 है. एक और बॉडी ले लो B, इसका टेम्परेचर T2 है. एंड सपोज T1 इज ग्रेटर देन T2. सो हीट विल फ्लो फ्रॉम अ बॉडी एट हायर टेम्परेचर टू द बॉडी एट लोअर टेम्परेचर. सिमिलरली वो कॉन्सेप्ट को याद रखिए. हमारा ये मानना है कि करंट फ्लोज फ्रॉम अ कंडक्टर having higher potential to a conductor having lower potential. इसका क्या मतलब होता है कि जो पॉजिटिव चार्ज बॉडी है हमारा, that is at higher potential, एंड जो बॉडी बी है जहां पे एक्सेस ऑफ इलेक्ट्रॉन है, यू नो, दैट इज एट लोअर पोटेंशियल. सो द करंट फ्लोज फ्रॉम हायर पोटेंशियल टू अ बॉडी एट लोअर पोटेंशियल, बट इलेक्ट्रॉन फ्लोज फ्रॉम अ बॉडी एट लोअर पोटेंशियल टू हायर पोटेंशियल. जस्ट रिमेंबर दिस. नाउ ये तो हो गया सिंपल डेफिनेशन. नाउ हाउ डू यू कैलकुलेट पोटेंशियल एट अ पॉइंट? Potential at a point. Just look carefully. Potential at a point is defined as the work done in bringing a charge, suppose Q, from infinity to that particular पॉइंट. यानी कि हम कह सकते हैं कि जो पोटेंशियल है मेरा, सपोज वी रिप्रेजेंट पोटेंशियल बाय V, then V is nothing. How it is calculated? Work done in bringing a charge from infinity to that point. So potential is given by W by Q, where W is the work done and Q is the charge. Now this was all about potential. Now when we talk about potential difference between 2 points, just look carefully. Potential difference between 2 points. Now what is potential difference between 2 points? Suppose V1 minus V2. Again, potential difference between 2 points is the amount of work done in moving unit positive charge, suppose Q, from point 1 to point 2. Okay, how much work is done from moving a charge Q, unit positive charge, from point 1 to point 2. That is your potential difference between 2 points. Clear? Now the unit for potential difference. Now we know potential difference is work done by Q. Q is the charge. Now the unit for potential difference, the SI unit is volt, V. So 1 volt is equal to, work done is in joule, so 1 joule, SI unit I'm talking about, and charge is in coulomb, 1 coulomb. So when 1 joule of work is said to be done in transferring a charge of 1 coulomb from one point to another point, then the potential difference between the 2 points is 1 volt. Am I clear? Remember this, okay? That the body with the deficiency of electron, which is positive charge body, is at higher potential, and the body which has excess of electron is at lower potential. So in a cell, you know, this is positive, this is negative. This terminal, you know, is at higher potential, and this terminal is at lower potential. That is why current flows from positive terminal to negative terminal, but electron flows from negative terminal to positive terminal. Now, one thing, in a cell provides us electricity, or electric current rather, for a considerable amount of time. Why? See, this is the thing. Now in a cell you have electrodes, you have cathode which has a excess of electron, you have anode which has deficiency of electron. So what happened inside the cell due to the chemical reaction, the excess of electron in the cathode and the deficiency of anode in the electron in the anode are maintained. So we get current for a long duration of time, because as soon as the concentration becomes equal, in this case suppose A and B, when the concentration becomes equal, जब यहाँ का number of electron, यहाँ का number of electron, you know, the concentration of the electron becomes same, तब तो current नहीं flow होगा, you know, then the electron will not move, current will not flow. So in the cell what do? हम लोग ये देखते हैं कि वो deficiency of electron और वो excess of electron maintained रहे by chemical reaction, तो हमको current थोड़ा ज़्यादा समय तक मिलता है. Okay, now let us discuss about resistance. Resistance, इसका मीनिंग होता है obstruction, which means simple term में हम कह सकते हैं the obstruction offered to the flow of electron by the conductor is known as resistance. जब इलेक्ट्रॉन मूव कर रहा है कंडक्टर में, तो कंडक्टर उसको रोकना चाह रहा है, उसी प्रॉपर्टी को हम लोग रेजिस्टेंस कहते हैं. फॉर एग्जाम्पल आप देखो, कोई भी एक वायर है, उसमें पॉजिटिव चार्ज बॉडी होते हैं जो कि मूव नहीं करते हैं, बट देयर आर इलेक्ट्रॉन्स ऑल्सो जो कि रैंडम मैनर में मूव करते हैं. इज इट क्लियर? Now if this conductor is joined to a cell, suppose इसको एक सेल से मैंने कनेक्ट कर दिया, दिस इज योर पॉजिटिव टर्मिनल एंड दिस इज योर नेगेटिव टर्मिनल। अब क्या होगा, अब जो इलेक्ट्रॉन है उनका मूवमेंट एक पर्टिकुलर डायरेक्शन में होगा, फ्रॉम द नेगेटिव टू द पॉजिटिव टर्मिनल, विच मीन्स अब जो इलेक्ट्रॉन मूव करेगा वो पॉजिटिव टर्मिनल की तरफ मूव करेगा। नाउ ड्यूरिंग मूवमेंट क्या होगा, दिस will collide, the electrons will collide with each other as well as the positive charge, as well as the positive charge within the conductor. That means उसको रोका जा रहा है, उसको आगे बढ़ने नहीं दिया जा रहा, but it will still move because there is a potential difference, but रुक रुक के move करेगा, which means electrons do not move, you can say, with accelerated speed, but they drift towards the positive terminal. So that is your resistance, obstruction offered to the flow of electron. Okay, now यूनिट ऑफ रेजिस्टेंस, उससे पहले हम लोग को ओम्स लॉ पहले डिफाइन करना पड़ेगा ना। ओम्स लॉ, ओम्स लॉ क्या कहता है, ओम्स लॉ कहता है कि द रेजिस्टेंस ऑफ अ वायर इज इक्वल टू द रेशियो ऑफ पोटेंशियल डिफरेंस across its end by the current through the wire, which means if resistance को हम लोग R लिखते हैं तो R is equal to V by I, where R is the resistance offered to the flow of electron, V is the potential difference across the end, and I is the current flowing through the conductor. Now what is the unit of resistance? Now the SI unit of resistance, the SI unit of resistance is ohm, OHM. The symbol is this. Is it clear? Now 1 ohm क्या होगा? How do you define 1 ohm? Now look, 1 ohm is equal to 1 potential difference is 1 volt, current is 1 ampere. SI unit I'm talking about. Now, a conductor will have a resistance of 1 ohm when a current of 1 ampere flows through it, having a potential difference of 1 volt across its end. Then the resistance is 1 ohm. Remember that, okay? And resistance, like potential, is a scalar quantity. Potential, as well as you can say resistance, these both are scalar quantity. Clear? Now factors affecting resistance of a wire. The first is your material of the wire. Now हमें पता है कि जो resistance है, it depends on the collision of electron with electrons and positive ions of a conductor. Now अलग अलग conductor में the number of electrons and the arrangement of atoms is different. So different, maybe the length of the conductor may be same, area may be same, but अगर material अलग है तो उनका resistance भी अलग होगा. For example, आप ले लो metals. Metals क्या होते हैं, वहां पे resistance low होते हैं because they are good conductor of electricity. They have more number of free electrons. Is it clear? दूसरा, so resistance depend on the material. दूसरा, length of the wire. Now अगर आप length को increase करो, ये दो कंडक्टर है आपका, इसका लेंथ ज्यादा है तो यहां पे जब इलेक्ट्रॉन मूव करेगा तो ज्यादा कॉलिशन होगा, which means इसका रेजिस्टेंस ज्यादा होगा, isn't it? यहां पे जब मूव करेगा तो नंबर ऑफ कॉलिशन विल बी लेस बिकॉज द लेंथ इज लेस, विच मीन्स द लेंथ इज डायरेक्टली प्रोपोर्शनल टू रेजिस्टेंस। अगर आप लेंथ को बढ़ाओगे तो रेजिस्टेंस भी वायर का बढ़ जाएगा। इज इट क्लियर? थर्ड फैक्टर, एरिया। ना लुको भैया, ये मैंने दो वायर ले लिया है, कंडक्टर्स, दोनों का लेंथ सेम है, बट एरिया A1 A2। नाउ A2 इज ग्रेटर देन A1, सो यहां पे इलेक्ट्रॉन के पास ज्यादा स्पेस है टू मूव, सो द कॉलिशन विल बी लेस एज कंपेयर टू दिस, इजंट इट? यानी कि यहां पे इस केस में सपोज रेजिस्टेंस R1 है और इसका रेजिस्टेंस R2 है, ओके, तो रेजिस्टेंस R1 will be less than R2, which means resistance is inversely proportional to area। अगर आप एरिया को इंक्रीज करते हो तो रेजिस्टेंस आपका कम हो जाता है। क्लियर? एंड द फोर्थ वन इज टेम्परेचर। Now, with the increase in temperature, what happened? The collision, of electron increases. So what happened? The collision increases. और अगर collision increase होगा तो जाहिर सी बात है रेजिस्टेंस भी इंक्रीज होगा। मतलब अगर आप टेम्परेचर इंक्रीज कर रहे हो तो नंबर ऑफ collision इंक्रीज होगा, तो रेजिस्टेंस भी इंक्रीज होगा। So on these four factors, the resistance of a wire depend. Material, we know good conductors have less resistance, bad conductors have more resistance. Length, if you increase the length of the wire, of course keeping the area same, then what happens? The resistance also increases. Area, if the length is same, the conductor having more area will have less resistance. Am I clear? Now let us do numericals from the exercise. Now look at sums from exercise 9b. The first one, in transferring 1.5 coulomb charge through a wire, 9 joule of work is needed. Find the potential difference across the wire. Very easy. We know potential difference V equals to work done by Q. Now work done is given as 9 joule and Q is given as 1.5. Okay, the point goes away, 10 comes over here, 5 2 times, 5 3 times, 3 times. So 6 volt. Isn't it? Look at number 2. A cell of potential difference 12 volt is connected to a bulb. The resistance of the bulb when it glows is 24 ohm. So resistance is 24 ohm. Find the current drawn. Now we know the Ohm's law. Ohm's law is resistance, we just did it, V by I, which is V equals to IR, or I equals to V by R, which means I will be 12 by 24, that's 0.5 ampere of current. Clear? Very easy. Now let us look at the next sum. Now look at number 3. A cell draws current, means I is given as 1.5 ampere at 6 volt. Potential difference is 6 volt. Find the resistance of filament of bulb while glowing. Same, we have just done it. V equals to IR. So R equals to V by I, Ohm's law. So V is 6 by 1.5, that's 4 ohm. Done. Look at the last one. A current 0.2 ampere, I is 0.2 ampere, flows in a wire of resistance 15 ohm. Find the potential difference. Now we know V equals to IR. So I multiplied by R. So that's 15 2 times 30. So that's 3 volt. Clear? So in this video, keep it till here. In the next video, we'll see a new chapter.